Yeah, we'd expect software-defined vehicles to bring significant cost benefits for automakers. And this is because we are going to see reduction of components in the vehicles. So instead of having one ECU per feature, we're going to have features being consolidated in very robust chips in single boxes. So Rivian, for example, now has 7 ECUs in their architecture. And this is compared to 150 ECUs in traditional architectures. And having less components also means that these cars are simpler. And simpler means faster to manufacture and easier to manufacture, which of course translates into cost benefits. Also, if you have less ECUs or electronic control units, that means you're going to have less cables in your cars. And cables are actually one of the most heavy components in vehicles today. So if you reduce this weight in the car, you're going to have better fuel efficiency, which means you can have better range in electric vehicles as well. And of course, you have virtual sensors. So instead of having the physical sensor, you can have a virtual sensor through software, or you can even do the processing from your sensor in a central compute, and moving from smart sensors that have processing to dumb sensors, the ones that don't have processing. So there's a lot of cost benefits that we can see in the overall vehicle architecture. So Leapmotor, for example, they say that transitioning to SDV architectures, they're saving $70 in their overall vehicle. However, I would like to be careful with this, because sometimes we are replacing cables with silicon, and silicon it's not cheaper than cables, right? So I wouldn't say that you would always have a cheaper bill of materials, but of course you have all the benefits that outcome this. Anna, how is this in manufacturing?
In manufacturing, the software-defined automation is a kind of new technology. We are at the beginning, but the same hardware reduction, cost saving on cables applied to manufacturing fully, and is especially important now in the time of disrupted supply chains. Also, we should think of cost of not implementing software-defined automation architecture. For example, the major driver of Audi implementing virtualized PLCs of Siemens and codices with the network supporting from Cisco is to save costs on upgrading and updating, patching legacy PLCs. You can imagine in a scale deployment that can take weeks or months, while with virtualized and software-defined approach, you can update and upgrade your devices within hours. While software-defined automation in manufacturing is in the beginning, and Audi example is just one well-known example of scaled implementation of those technology. I'm wondering, how is it in automotive with software-defined vehicle?
That's very interesting. First of all, I love your concept of the cost of not implementing a software-defined architecture. I would say that software-defined vehicles are ahead of automation in manufacturing, but we are still at the beginning compared to manufacturing or telecom industries, right? And what we are learning now is that there must be a massive change in business models and organizational structures. So you cannot decide the components in your vehicle based on the bill of materials. You have to decide this based on the total cost of ownership. Because when you have a software-defined architecture, you're going to have costs during the life cycle of your device, meaning you need to have revenues as well. But Anna, I really love that we can have this discussion, because this digitalization processes has happened in several other industries. And I think the key point now, it's learning from the industries that have been through this transition already. So thank you very much for this chat.
Thank you for conversation, and contact us for more information.